Hi and Assalamualaikum. We are from Group 13. We're going to present about determination of sulfur dioxide in fruit juice. Right now, I will briefly tell you about sulfur dioxide. Sulfur dioxide employed in various foods since the 1970s extends shelf life by inhibiting microbial growth and slowing oxidation. It preserves colors, vitamins, and flavors, proving particularly useful in fruit juice. Despite its benefits, the FDA banned its use in fresh fruit and vegetables in 1986 due to health concerns, especially for asthma sufferers. This compound, while instrumental in food preservation, it has faced a restriction to ensure consumer well-being. Next, we need to know that sulfur dioxide use has both advantage and disadvantage, which are important to consider. For the advantage, this chemical can prevent bacteria, yeast, and mold growth, extending fruit juice shelf life. It's also relatively cheap to produce with widely available raw materials. Lastly, it can maintain natural color in light color or delicate fruit juice, preventing browning reaction. For the disadvantage, it may cause coughing, mucus reaction, and bronchial conditions like asthma and chronic bronchitis. Not just that, it's also known as nutrient loss because it can contribute to the degradation of vitamins and elements in fruit juice over time. Lastly, it can affect environment when it's combining with water and air, leading to acid rain with potential impacts on deforestation, aquatic life, and building materials.
Next, for literature review, our first article is UV-Vis irradiation, an alternative to reduce sulfur dioxide in white wine. First, this document discusses about ultraviolet UV-Vis as a way to reduce use of SO2 in production of white wine. Second, this article tells us about preventing wine from spoiling at the same level as sulfur dioxide without changing a quality like pH, tartaric acid, and alcohol content. And number 3, addition of sulfur dioxide was necessary to show the improvement of the optimal process like wine color parameters. And number 4 is the result show that UV-Vis irradiation is a method to reduce sulfur dioxide in winemaking, but further research is needed to optimize the process and ensure wine quality.
In the view of the Lental journals, technique that use high-resolution continuous source molecular absorbance spectrometry to identify amount of free and total sulfur compound in sample of coconut water. This journal also mentioned that a class of chemical known as sulfide agent are used in the preparation of food and beverage. It can be used in food preservation and function as an antioxidant to stop or lessen the deterioration of food and beverage. This is because certain group of people may experience allergy response to this chemical. On the other hand, the form of sulfide that are permanently bound are highly stable chemical compound with intricate determination. Thus, total sulfide is the sum of free and reversibly bound sulfide.
For the standard solution preparation, in this experiment, we prepared two types of the stock solution, which is sodium sulfide stock solution and fruit juice stock solution. For the sodium sulfide stock solution, we use 1.26043 gram of 0.1 m sodium sulfide is used as a stock solution in a 100 milliliters volumetric flask Accurate reading should be taken as a preventive measure to avoid data analysis having significant error. Each apparatus that is used is rinsed with distilled water to eliminate all residual material that dissolve in the water. In the preparation of the fruit juice stock solution, fresh orange juice was used for this experiment. Fruit juice is filtered. Use filter paper to separate it from the pulp.
So the next part is calculation volume of sodium sulfide for stock solution. First step is calculate the weight of sodium sulfide in 100 ml volume. Moles of sodium sulfide, which is 126.043 gram per mole, is equal to 0.1 mole. Next, we calculate the gram of sodium sulfide, which is 0.1 mole per liter times 126.043 gram per mole is equal to 1.26043 gram in 100 ml volume. The volume transferred from the stock solution will be calculated by using the dilution formula, which is M1V1 is equal to M2V2. We already find the volume that need to be transferred, which is 50 ml, and also this calculation already shown in this table. In addition, we also provide a graphic about serial dilution of chemical to enhance our understanding.
UV-Vis spectroscopy analysis. The absorbance was measured between 200 nanometers and 700 nanometers. The maximum wavelength used to find concentration is 532 nanometers. A total of 7 cuvette measuring 1 centimeters by 1 centimeters are used to be read by this machine, including distilled water, a stock solution of sodium sulfide, and a sample solution of orange juice, but only a few accurate readings are used to record the exact curve line. Microsoft Excel was used to create a graph of adsorbent against the concentration of sodium sulfide and display the scan wavelength result. The analysis data obtained will be stored in blank CDs.
We select for the best point from the data above in order to create a nice linear relationship of UV-Vis calibration curve between sodium sulfide concentration and absorption. Based on the graph, the molar absorption may be determined using the curve slope. As shown in the graph, the correlation coefficient value should be 0.95 and above, but we only achieved the correlation coefficient value of 0.8963. This is because there was an error during the experiment.
For the concentration of sulfur dioxide in the fruit juice, we need to calculate the concentration. So, the absorbance of the fruit juice that we use is 0.8038, and the formula that we use for this calculation is y equal to mx plus c, where y is absorbance of the fruit juice, m is the parameter, x the concentration of the sulfur dioxide in the fruit juice, c is the y-axis acquired from the graph. So, we insert all the data given to the formula y equal to mx plus c, and we get the concentration of sulfur dioxide in the fruit juice was 1.7403.
In conclusion, sulfur dioxide is important in certain industrial processes and as a preservative. Furthermore, as we know, the use of sulfur dioxide has their own advantage and disadvantage for us. In this experiment, we found that the coefficient of determination is below the 0.95. This may happen because of the relationship between absorption and concentration may not be accurately discovered by a simple linear model. Other than that, the experimental errors or uncertainty might be in measuring absorbance or concentration could contribute to the variability in the data. In the future, More research and collaboration is needed to better understand the complexity of sulfur dioxide emissions, create new solutions, and implement successful strategies to reduce their impact on air quality and overall environmental well-being.